Buffer questions. I'm going to run through a series of 4 questions now. The first one is the easiest of the 4. This is making a buffer from a salt and a weak acid. We're told the Ka, and you have to work out the pH. Now, to work out pH, you need to know what the H plus concentration is. So what we use, because this is a buffer, we use the Henderson-Hasselbalch equation, so we can jump straight to this one here. Okay, and then what we need to do is we just need to, account for what we know and what we don't know. Well, we know that the Ka is 1.74 times 10 to the minus 5. We know that the excuse me, we know that the concentration of the weak acid is 0.01. We're trying to work out the H plus, so then we can work out the pH. So we need to work out the number of moles. Sorry, not the number of moles, the concentration of A minus before we do anything else. So, first thing to do, work out the number of moles of A minus, which is this here. So that's going to be equal to 2.05 divided by the MR of the sodium ethanoate, which is 82.1, and we get 0.025 moles. Now that's moles. We need concentration, hence the square brackets. So the next thing we need to do is to convert this into concentration, and to do that we're going to use MV over 1000. We're going to work out what M is, so it's 1000 N over the volume. Now this is the volume of the buffer in total. So sub your values in to here, and we find that the concentration is 0.05 moles per decimeter cubed. Okay, and that is our A minus value. What we then need to do is then plug it into our Henderson-Hasselbalch equation, and we'll find out what the H plus concentration is, and we find out that it is equal to 3.48 times by 10 to the minus 6. Last thing we do then is to work out the pH by using the minus log of 3.48 times 10 to the minus 6, and we find out that the pH is equal to 5.46.